This example demonstrates an application of the OptiLayer Pro Filter Design mode for designing coarse WDM filters. These filters require a fairly wide transmission band with a spectral width of 15 nanometers and adjacent band rejection better than minus 30 decibels at a spectral distance of plus or minus 10 nanometers from the filter central wavelength. Thus, such filters must have very steep slopes between the high transmission and high reflection zones, necessitating the use of multi-cavity filters with large numbers of layers. As an example, designing of a filter with 1530 nanometer central wavelength is considered. In the File Arrow Project menu of OptiLayer, open the directory LEC25D9-2. Load into RAM the data files needed to run this exercise. These are the substrate 1.52 and the layer materials 2.00 and 1.45. In the Synthesis menu, select the Filter Design mode. It is organized as a 6-step dialog. The first step is to select the layer materials used to design the filter. CWDM filters are 2-component multilayers and 2 materials with refractive indices 2.00 and 1.45 have been loaded into RAM, and their selection has been already checked. By clicking the Next button, we move on to the second dialog step, where the parameters of the design filter are set. We will design a filter with the filter central wavelength of 1530 nanometers, 7.5 nanometers half width at the 89.13% transmittance level, corresponding to an attenuation of 0.5 decibels, and 10 nanometers half width at the 0.1% transmittance level, corresponding to an attenuation of 30 decibels. Click the Next button to move on to the third dialog step. At this step, the number of spacer layers, the number of filter cavities, is set. The recommendation for this number follows from the theory of Chebyshev filters. It is that the required number of cavities should be greater than 7. Let us set 8 here. At the next fourth step of the dialog, a filter prototype is selected. The parameters of the filter prototypes M, the number of the first mirror layers, NK, the spacer order, are listed in the left part of the Step 4 window. Increasing the K value corresponds to the use of thicker spacer cavity layers in the selected prototype. Let us start with the bottom row of the prototype selection sub-window. M equals 8, K equals 1. After one of the filter prototypes has been selected, we move on to the next fifth dialog step. At this step, the filter parameters will be optimized. These parameters are the numbers of layers of quarter wave mirrors that make up the filter and the orders of the filter spacer layers. The optimization procedure can be performed with applying 1 or 2 layer AR coating at the top of the filter design. This choice can be done at the 6th dialog step before running the optimization procedure. Let us make the 2-layer AR coating selection at this step and return to the Step 5. A special integer optimization procedure is launched when you click the Start button in Step 5 window. Optimization is remarkably fast, and within a few seconds you will see excellent results displayed in the right side of the Step 5 window. We can try to achieve even better results using other prototypes from the Step 4 window. Let us return to this window and select the prototype, M equals 7, K equals 3. Return to Step 5 and click the Start button. After a few seconds, a noticeably better result will be obtained. Let us move on to Step 6. Clicking the Finish button will place the obtained design in the GI, General Information window. We can then examine the result using the T and R and phase and refractive index profile windows. The obtained design is stored in the design database under the name Filter Design at 1530 nanometers, 8 cavities. The filter design mode uses exceptionally efficient optimization procedures, and you can try to obtain other filter designs using other, higher numbers of spacer, cavity layers, and different filter prototypes. For example, another design with 11 spacer layers is stored in the design database under the name Filter Design at 1,530 nanometers 11 cavities. Load this design and examine it using the TNR and Phase and Refractive Index profile windows.